Today we are going to dive deep into the heart of Azure Functions by mastering two of its most powerful concepts, triggers and bindings. If you are looking to build modern event-driven serverless application without getting bogged down into boilerplate code, you are in the right place. Let's get started. Here is a quick look at our roadmap for today. We will start with a brief overview of what Azure Functions actually are. Then we will move into the core model, the real value of this presentation, taking a deep dive into triggers and bindings. We will walk through some of real code examples, look at how these pieces fit together in a real world architecture pattern, and wrap up with some essential best practices for running this in production. First, let's do a level set. What is Azure Functions? At its core, it's Microsoft Azure Serverless Compute Service. Serverless doesn't mean there are no servers, it just means you don't have to create about them. You simply write a small focused piece of code, a function that executes in response to an event. Azure completely handles the infrastructure, the scaling, and the execution. Best of all, you are only built for the exact milliseconds your code is running. It's highly efficient and keeps you focused on solving business problems, not managing servers. If you look at below, triggers and bindings are very important. We are going to deep dive today. And if you see on the right side, you have supported language to write your Azure functions. To really master Azure functions, you need to understand the mental model. Think of your functions in three parts: the trigger, the code, and the bindings. The trigger is the when, it dictates exactly what event causes your function to wake up and start running. The code is the how. This is your custom C Sharp, Python, or JavaScript logic that does actually work. The bindings are the what. This is how your code interacts with other services, how it pulls data in or pushes data out without you having to write complex SDK connections. The golden rule to remember is every individual function must have exactly one trigger, but it can have 0, 1, or many bindings. Let's zoom in on triggers. The trigger is the execution spark. It doesn't just start the function, it also carries the payload or the event data. For instance, if a file is uploaded to a storage, the trigger wakes up the function and hand over the details of that file. Triggers follows a strict single responsibility principle. A single function cannot be triggered by a queue message and an HTTP request. You would write two separate functions for that. Also, the trigger dictates your scalability. If you have 10,000 messages suddenly drop into a queue, Azure looks at the trigger and automatically spins up multiple instances of your Azure functions to process them in parallel. Just make a note, one function can have only one trigger. So let's look at what kinds of events can start a function. Azure provides a rich catalog of triggers. HTTP triggers are your standard webhooks and REST APIs. Timer triggers run on a schedule like a nightly batch job. Blob triggers reacts immediately when a file is created or uploaded in Azure storage. Cosmos DB triggers listen to a database change feed, perfect for updating a search index when a database record is changed. And finally, messaging triggers like queues, service bus, event grid are used to build highly decoupled asynchronous systems. Let's look at what this actually looks like in C Sharp code. On the top, we have an HTTP trigger. Notice the HTTP trigger attributes inside the method signature. That one line of code exposes this function as a REST endpoint. Someone hits the URL with a get or a post request. The function runs and we return an OK object result saying hello from Azure Functions. If you look at the bottom, we have a timer trigger. Inside the attribute, you see a string of numbers and asterisks 008 and asterisks. That is a cron expression. It tells Azure to run this function exactly at 8 a.m. UTC time every single day. Once you learn this cron syntax, it is incredibly powerful scheduling automated tasks like a daily reports. Now that we know how to start the code, let's talk about the bindings, the connectors. Bindings are a declarative way to connect your function to other Azure services. Instead of writing 20 lines of boilerplate code to authenticate, open a connection, and instantiate a Cosmos client or a Blob client, you just declare what you want in the function signature. Bindings have directions. They are either input, bringing data into the function, or output, sending data out. Unlike triggers, bindings are totally optional, but they are the secret to keep your code clean and manageable. Let's break down the input bindings. This allows your function to pull additional data the moment the trigger fires. Imagine an HTTP request comes in with a user ID. Instead of writing database connection logic to go and find that user, you can configure an input binding. Azure will automatically take that user ID from HTTP request, go to the database, fetch the user profile, and hand it to your code as a pre-populated parameter. Your code just receives the data and start working. When it comes to output binding, it works opposite direction to the input binding. They push data out when your function finishes. Let's look at this fantastic code snippet to see it all together. Let's look at the parameter for run. First, queue trigger string order ID. This is our spark. A message arrives in the queue and the function starts. Second, blob string receipt. This is an input binding. Azure automatically goes to blob storage, find a receipt matching with that order ID, and passes the file content to your code. Third one, table out order entity log. This is our output binding. Notice that we have a out keyword here. In the body of the function, all we do is create a new order entity and assign it to the log variable. When the function ends, Azure automatically connects to a table storage and save that record. There are no connection strings in the code, no retry logic, and no SDK initialization. Just pure readable business logic. While writing Azure functions, if you are writing in C Sharp, you use the attributes we just saw. But if you are writing your Azure functions with the languages like JavaScript, Python, or PowerShell, the magic happens in a file called function.json. As you can see in this JSON snippet, we define an array of bindings. We specify the type, the direction, in or out, and the connection string reference. The Azure function runtime reads this file, handles all the heavy lifting behind the scenes, and injects the data directly into your JavaScript or Python arguments. We understood about triggers, input and output bindings. Let's zoom out and look at a real world scenario, an e-commerce ordering processing system. How does this look in practice? Step 1, a customer clicks buy option, an HTTP trigger receives the payload and uses a service bus output binding to safely queue the order. Step 2, a service bus trigger wakes up. It uses a Cosmos DB input binding to fetch the user profile, process the payment, save the results via a Cosmos DB output binding, and drops a message into another queue. Step 3, that new message fires a queue trigger, which uses a SendGrid output binding to instantly send an email confirmation to the customer. Step 4, meanwhile, the database update triggers a blob trigger, which generates a PDF invoice and saves it. Step 5, finally, a timer trigger wakes up at midnight, uses an input binding to grab all the daily orders and pushes them into a data warehouse. Notice what we just described: 5 separate functions doing exactly one job each, passing data seamlessly via bindings. And you did not have to provision, patch, or maintain a single server to do it. Before we wrap up, if you are going to put this in production, keep these professional design patterns in mind. Idempotency. Because of how distributed system works, a trigger might occasionally fire twice for the same event. Design your code so that running it twice doesn't duplicate orders or corrupt data. Next, error handling. Always configure dead letter queues. If a message fails to process after a few retries, it should be moved aside safely so it doesn't block the system. When it comes to security, never hardcode connection strings. Keep them in your Azure Key Vault or use Azure Managed Identity so your bindings authenticate securely without passwords. When it comes to isolated worker model, make sure you decouple your code from the Azure host. And the last one, functions should do their job quickly. If you have a process that takes 15 minutes or requires complex workflow logic, look into durable functions instead. Let's recap. Azure Functions gives you the power of serverless compute. Remember the mental model. The trigger is the when you get exactly one. The binding is the what, giving you input and output access to the Azure ecosystem with almost zero boilerplate code. Using this model results in faster development, highly readable code, and effortless scaling. If you want to learn more, I highly recommend checking out the Azure Functions University on GitHub or the official Microsoft Learn modules. Or you can watch my Azure Functions playlist. That brings us to the end. Thank you so much for watching. If you found this helpful, please like, share, and subscribe to the channel. And don't forget to hit the bell icon for notifications on the future videos. Thank you for watching. See you in the next video.